What's up, guys? It's Talha here, and today what we are going to discuss is will be about the derivatives of trigonometric functions, the derivatives of trigonometric functions. Of trigonometric functions, and then if we have time, then we are going to discuss chain rule. I'm going to explain what is chain rule and how you can and why do we use it, and in what situations do we have to use it, and what's the benefit of using it, and then um, that's it. So we are going to discuss these two things today. So coming to our first topic, that is derivatives of trigonometric functions. So what are trigonometric functions? The trigonometric functions are our the six basic functions. We have sine, cosine, tangent. We have cosecant. Now we have yes, for sine we have cosecant. For cosecant we have secant, and for tangent we have cotangent. So sine, cosine, tangent, cosecant, secant, and cotangent. So the derivatives of these functions are, let's first I'm not going to prove the derivatives of every trigonometric function. I'm just going to do it for the sine, and the rest you can look them up in the book or up in that the derivatives of then the proofs are everywhere. I don't have that much time to prove every one of them, so I'm just going to do it for the sine. So sine. So how do you find the derivative? So from the first principal rule, as we know that when limit of h approaches 0, you have f of x plus h. So we have y equals sine. So that means f of x equals sine, and y equals f of x, and f of x equals sine. So f of x plus h minus f of x divided by h So this is the first principal rule which we will use to find the derivative of sine. So we write it as it is, and for the sine we put f of x plus h. So that means sine of x plus h minus uh, minus minus sine of x divided by h. So now here, as we know, this is the formula sine of a plus b, or sine of x plus h. So sine of a plus b equals sine of a into cos of b minus, it's minus, right? Let me just confirm if it is minus. Let me no, it's plus. So plus sine of a cos of b plus cos of a and sine of b. So right here we are going to implement the formula for sine of x plus h, and we are going to replace x plus h by a and b. So this is going to be equal to sine of x into cos of h plus cos of x into sine of h. Right? Yes, minus sine of x minus sine of x, and it is going to be divided by h. So now what we are going to do is take the sine of is now what we are going to do is open the now what we are going to do is we are going to open the bracket and sine of x and cos of h and minus sine of x we can put them on one side, and this plus cos of x sine of h. Oh my god, this pen is like cos of x sine of h can be on this side, and this whole term can be divided by h. So right here, limit of h approaches to 0, you can take sine of x common. So sine of x, this will be cos of h minus 1 plus cos of x sine of h divided by h. And what you can do now is write them separately. So you're going to have sine of cos h minus 1 or you can say sine of x into cos of h minus 1 divided by h plus and this is going to be plus cos of x into sine of h divided by h. And now what you're going to do is you're going to apply the limit to because according to the summation rule, if two functions or if two functions are being if two expressions are being summed up, so you can apply the limit to each one of them. So you can apply the limit, and so the limit of h approaches 0 will be applied to sine of x into cos of h minus 1 divided by h, and it will be applied to cos of x dot sine of h divided by h. So when you will apply the limit to this expression, this will be, so cos of 0 will be right, so when this limit will be applied, so it will be sine of x into, when limit of h approaches 0 to cos of h minus 1, so it will be 1 minus 1, 0 by 0, so it will be sine of x into 0 plus, and when you apply the limit right here, it will be cos of x into 1, and this term will be 0, so you will get cos of x in return. So the derivative of sine of x equals cos of x, and I just proved it right here. The same, so the derivative of sine of x is cos of x. Now there are a lot of proofs, so here the derivative of cos of x is minus sine of x, and you can watch the you can check out the proof. I'm not going to do it. For tangent, you have secant square for the derivative of tangent. For cosecant, for the cosecant, you have minus cosecant. For cosecant, the derivative of cosecant is minus cosecant x into cotangent x. For secant, you have secant into tangent x, so it's x everywhere, it's x. And lastly, for cotangent, you have minus cosecant square. So these are the derivatives of individual trigonometric functions, which you guys need to remember, and this will help you solving the derivatives for the trigonometric functions. Now let's jump to our second topic, that was chain rule. So first of all, let me just define what is chain rule. So when you have a composition of a function, so for example f of g, so this right here is the composition of a function. So when you have a composition of a function and you have a derivative of that, for example, I say that you have a derivative of x square plus 2x whole power 3. So you have a derivative of that. Now what what's happening is that you have a function. For example, we can consider it g of x, so we can consider x2 plus 2x as g of x. So this is one function, and this and so if we consider it g of x, so f of g of x, so if g of x equals this, f of g of x equals x power 3. So now when we so this is a composition, so this function right here is a composition of g of x, is the composition of f of x and g of x, so means f of g of x. This function, you can say that it is f of g of x, a composition of two functions. So now when you are going to put so f of x was x cubed. Now instead of f of x, it's g of x, so you're going to replace x by g of x, and g of x is x squared plus 2x. So what you're going to do is that will be x squared plus 2fx whole cube. So what chain rule says is, if you have a condition like this right here, so how you're going to find the derivative, you're going to find the derivative. So the formula, or what chain rule says is that the way you're going to find the derivative is, first you're going to find the derivative of f when it contains g of x into the derivative of g of x. So that means what chain rule says is you're going to find the derivative of f on the point at the value of g of x, and then you're going to multiply that by the derivative of g of x itself. So let's solve this question right here according to this rule right here. So first, what we are going to do is find the derivative of f of x, and f of x was, remember, x power x cube. F of x was x cube. So the derivative of x cube is 3x, right? It's 3x square, 3x square, and instead of x we had g of x, and g of x is x square plus 2x. And now what you're going to do is multiply by the g of x's derivative itself, and the derivative, so remember g of x was x, and the derivative of g of x is, so the derivative is 2x plus 2. So this right here is the derivative of uh, this function right here. So 3 of x squared plus 2x whole square into 2x plus 2 is the derivative of x squared plus 2x into whole power 3. So let's do another example. For example, we have a question. For example, we have a question like find the derivative of x cube plus x cube plus 5x squared plus 3 whole power 6 minus x squared plus 5 whole power 2. So here we are going to apply the chain rule 2 times. So first for this function and then for this one. So as I said, first we are going to find the derivative of f, the whole function. So this will be equal to 6 and 6 of the x, and x is g of x, which is this, and 6 minus 1 is 5, and then x cubed plus 5x squared plus 3 into the derivative of g of x itself, so that will be 3x squared plus 2 into 5 is 10 x, and derivative of 3 is going to be 0. So this right here is the derivative of this first function and this first expression, and minus, so minus 2x, and x is x squared plus 5 into the derivative of this itself, so 2x plus 0, so it will be 2x. So this this right here is the derivative of x cubed plus 5x squared plus 3. And also we have a little time, so what we are going to discuss now is going to be about let me see, it's going to be about, yes, it's going to be about implicit differentiation. I forgot to mention at the beginning that implicit differentiation. So what is implicit differentiation? So all up till now we have been doing differentiation when you have explicitly. So explicitly means that you had y on the left hand side at one side, and you have the function of x on the right side. But what does implicit mean? Implicit means, so this right here, this is explicit. So y is explicitly differentiated when we have explicit differentiation. But when we have implicit differentiation, what you have is, you have, for example, you have a function as y squared plus x squared equals 20. So this right here is the equation of the circle. But right here we have this function is going to be implicitly differentiated. But it's up to you. You can just what you can do, you can shift x to the right side, so that will be 20 minus x squared. And now still the y is not alone, it has a square on top, so y equals 20 minus x squared whole under root. So if you want to do it this way, so this right here means that you're going to do it explicitly. But if you do it implicitly, means that if you keep x on the left side with y, and you keep the square on y, if you also keep the square on y on the top of y, and you differentiate the same way. So if what it's going to have is d by dx of if with respect to x, y square plus d by dx of x square equals 20. So 20 means d by dx of 20. So what this is going to be equal to, this is going to be equal to 2y, and again derivative of y, we are using chain rule because it's with respect to x, plus it's going to be 2x, and again x will be 1 equals 0, and 2y into y derivative equals, so that you can shift plus 2x there, so it will be minus 2x divided by y derivative. uh, no no. Okay, so 2y dot y derivative equals minus 2x, and y derivative is going to be minus 2x divided by 2y, so it's going to be minus x by y. So y derivative, so the derivative of this equation right here, uh, implicitly we differentiated implicitly and we got y derivative, or dy by dx equals minus x by y. Alright guys, I'm going to take your leave. I hope my lecture helped you somewhat, and goodbye.